Um, Physics chapter 19, theory video 2, observing oscillations. Many oscillations are too rapid or too small for us to observe. Our eyes cannot respond rapidly enough if the frequency of oscillation is more than about 5 hertz. So that means 5 hertz means it passes through the central resting positions 5 times per second. Anything faster than this appears as a blur. In order to see the general characteristics of oscillating systems, we need to find a suitable system that oscillates slowly. Box 19.1 describes 3 suitable situations to investigate. So, the fact is that most of these vibrations or most of these oscillations are too fast or too small for us to observe. So, as a result, we have to have another mechanism to make sure that we can observe them and see how they how they show their characteristics. The first thing is a mass spring system. So that is two springs are attached and held in place, tethered uh, held in place and tethered by springs in between two clamps, right? Now what you do is, as shown in this diagram, as you can see there, you can see that there is a trolley, and it is tethered to a clamp here and another clamp here. On both sides it has been tethered. So then if you pull this trolley to one side and release it, it will oscillate back and forth along the bench, right? So then you will be able to actually see the characteristics in this, and you will see that it is moving. They are asking where is it moving fastest. You will see that it actually travels the fastest. You will hear that it is traveling the fastest right in the middle. That is when it is passing the midpoint. Then it slows down and comes to a rest at the far end and accelerates until it comes to the central point. Then it slows down once again. So let's see how that happens. Yeah. So now what basically happens is this. Let me let me see. Let me edit this. All right. So what happens is basically, now this is, let's say this is the midpoint. When you pull it to this point and release, it will travel back to this place and come back again to this point. So that is how it goes back and forth. So what basically happens is, now when it goes to this side, that is when it goes to one side, right, from here to here, when it goes and returns to this point, right? So these are the two extreme ends. So when it starts from here, it accelerates up until this point. It is accelerating. So at this point you have the highest velocity, and then it decelerates and come to rest at that point, right? By this point it has zero velocity. Then it accelerates once again, and at this point, once again at the middle point, you will have the highest velocity. Decelerates and comes to rest. So it happens back and forth, as you can understand. So basically that is the whole idea. What is this? Then they are asking what is happening to the springs as the trolley oscillates. What happens? So obviously when it comes to this end, when the trolley is here, what has happened to this spring? It has it has reduced in length, right? This has stretched. It has stretched. One spring, when it goes to the other end, one spring stretches, the other one will shorten in length. So what is that? Compressions and rarefactions. You have learnt about that in your O levels. So that is one way of observing um, these phenomena. That is the movement in an oscillation. Then a long pendulum. A string at least 2 meters long hangs from the ceiling with a large mass fixed at the end. Pull the mass some distance to one side and let go. The pendulum will swing back and forth at its natural frequency of oscillation. Try to note the characteristics of this motion. In what ways is it similar to the motion of the oscillating trolley? In what ways is it different? So you will be able to actually do this experiment, and I suggest you do that. From a higher up point, you hang a big a long thread and to the bottom of that you must attach something heavy and allow it to oscillate and find out how it acts in comparison to the earlier situation. So you will see once again it will have the same, almost all the characteristics would be similar. That is, for one thing, in the trolley, everything is traveling back and forth. The travel is along not along a circular path, but in a straight line. But in pendulum, it would be going in a circular pattern. It will be traveling in a circle or a part of a circle, an arc length. It will be traveling along an arc length. But it will have some characteristics which are similar. That is, it will have, because it would be moving like this. If this is the pendulum, it will go like this in a circular pathway, right? And then back again. So this pendulum will actually, once again, the highest velocity would be at the middle, right? It would have the highest velocity at the middle. Then we can see a loudspeaker cone, a signal generator. So loudspeaker cone means something like this is the loudspeaker, and a setup that contains a loudspeaker, and this is the loudspeaker cone. A signal generator set to a low frequency, right? So low frequency would result in a movement only that is observable frequency for us. Drives a loudspeaker so that it vibrates. You need to be able to see the cone of the loudspeaker, right? How does this motion compare with that of the pendulum and the mass spring system? Try using a higher frequency, say 100 Hertz. Use an electronic stroboscope flashing at similar frequency to show up the movement of the cone. Stroboscope is kind of a light system that kind of acts as a flash, so that freezes the movement, and so we can see how it is moving. It may help to paint a white spot on the center of the cone. Do you observe the same pattern of movement? Right, so you will actually see that the movement is quite similar to the first example. It is moving up and down, and it will still have the highest velocity at the middle, but when you increase the frequency, obviously the frequency is going to be very high. Write a note. To observe oscillations, we need to create a setup. We need to create a setup which provides a lesser frequency than 5 Hz, which is usually the limit of our eye to see the oscillations. A mass spring system or a long pendulum can be used to observe slow oscillations, and we will observe that the highest velocity would be at the center it slows down when it goes to the left and to the right, comes to a complete stop at the extreme ends, and accelerates, comes to a stop at the extreme ends, and accelerates until it reaches the central point or the resting position, and then decelerates until it comes to a rest at the other end. I hope you understood. The same phenomena takes place, next line, the same phenomena will take place if we observe the movement of a loudspeaker cone using a signal generator and a stroboscope. I hope you understood. If you have any questions, please ask.